Machu Picchu. You have seen the photos, the iconic stone citadel perched impossibly on a mountain ridge in Peru, with clouds swirling around ancient walls and tourists snapping selfies with llamas. It is presented as the lost city of the Incas, built around 1450 CE and abandoned a century later during the Spanish conquest, a triumph of Inca engineering and architecture. But walk past the Instagram crowds and look closely at what is actually holding this entire site together, and you will find something that does not quite fit the story we have been told. Something that modern engineers cannot fully explain, let alone replicate. The terraces, those stepped platforms cascading down the mountainside, are not just decorative. They are the foundation of everything. Without them, Machu Picchu would have slid down the mountain centuries ago. And here is what makes them extraordinary. They have survived over 500 years of torrential rainfall in one of the wettest regions on Earth without failing. No erosion, no landslides, no structural collapse. They should not work this well. Modern terracing systems in similar environments fail within decades, yet these keep functioning perfectly as if they were built yesterday. Think about what that actually means. Machu Picchu receives approximately 1,900 millimeters of rainfall annually. That is over 6 feet of water hammering down on steep slopes every single year. The site sits on a geological fault line in an active seismic zone. Earthquakes are routine. The mountain itself is composed of fractured granite that wants to slide down slope. Every engineering principle says this location should be impossible to build on permanently, and yet walk through Machu Picchu today and you will see terraces functioning exactly as designed, drainage systems flowing efficiently, not a hint of the catastrophic failure that should have happened centuries ago. The conventional explanation is straightforward. The Incas were brilliant engineers who understood drainage and soil mechanics. They built multi-layered terracing systems with rocks, gravel, sand, and topsoil that channeled water away from the structures. It is presented as impressive but achievable with dedication and labor. Clever ancient people solving problems with available materials. But here is what that explanation glosses over. We are not talking about simple stone walls holding back dirt. We are talking about a sophisticated hydrological engineering system that performs at a level modern civil engineers struggle to match with contemporary materials and knowledge. In the 1990s, archaeologists Kenneth Wright and Alfredo Valencia spent years studying Machu Picchu's drainage systems. What they found was startling. The site contains approximately 600 terraces, but that is just the visible surface. Below ground, they discovered an extensive network of drainage channels, water filtration systems, and subsurface engineering that represents about 60% of the total construction effort. 60%. Most of the actual work at Machu Picchu is hidden underground, invisible to tourists, doing the unglamorous job of managing water. Wright described it as one of the most sophisticated drainage systems he had encountered anywhere, ancient or modern. But here is where it gets interesting. The terraces are not just holding soil, they are engineered in layers with specific materials placed in precise sequences. At the bottom, large stones create drainage channels. Above that, smaller rocks and gravel act as filters. Then sand, then clay-rich soil, then topsoil. Each layer serves multiple functions: structural support, water filtration, root space for plants, earthquake damping. The system is redundant, self-regulating, and apparently permanent. When Wright's team analyzed the subsurface architecture, they found that groundwater was being intercepted, filtered, and channeled away from structures with extraordinary efficiency. Water that could have destabilized foundations was instead turned into an asset used for agriculture and domestic purposes. Think about what that actually requires. Whoever built this did not just understand that water causes problems. They understood hydrology at a fundamental level. They knew about water table dynamics, about hydraulic head, about soil permeability, and how different materials interact with flowing water. They knew that water weighing down a terrace will eventually cause collapse, so they designed systems to ensure water never accumulates. They understood earthquake dynamics, and they built in flexibility so the entire structure could absorb seismic shocks without rigid components shattering. This is not trial and error. This is applied engineering physics, and here is what makes modern engineers uncomfortable. When they have tried to build similar systems in comparable environments using traditional methods, they do not achieve the same results. Modern terracing projects in Peru and other mountainous regions routinely experience problems that Machu Picchu's terraces do not have: erosion, drainage failure, structural settling, vegetation damage to walls. Those systems require constant maintenance and eventual reconstruction. Machu Picchu's terraces just keep working. After more than 5 centuries of continuous exposure to rainfall that should have destroyed them, they are still functional, showing remarkable durability. How? The stones themselves present another puzzle. The terrace walls are built without mortar, using a technique called ashlar masonry, where stones are cut and fitted so precisely that you cannot slide a knife blade between them. Not everywhere, but in key structural locations. These are not roughly shaped rocks stacked together. These are stones that have been shaped with extraordinary precision. Their faces ground to tolerances measured in millimeters, their angles calculated to distribute weight and resist lateral pressure from soil and water, and they are fitted together in patterns that suggest a deep understanding of structural mechanics. Look at the way individual stones are shaped. They are not simple rectangles. Many have complex polygonal faces with multiple angles and protrusions that interlock with neighboring stones like a 3-dimensional jigsaw puzzle. This is not decorative. It is functional. The interlocking design distributes loads across multiple contact points, prevents individual stones from shifting, and allows the entire wall to flex slightly during earthquakes without coming apart. It is the same principle used in modern seismic engineering, where buildings are designed to absorb movement rather than resist it rigidly. Yet this is being done with rocks, without steel reinforcement, without concrete, and without the mathematical modeling and computer simulations modern engineers rely on. Engineers who study these walls calculate that shaping stones to this degree of precision would require metallurgical capabilities beyond what is attributed to the Incas. Bronze tools, which the Incas had, can work granite, but slowly and laboriously. Creating the smooth, precise surfaces found in Machu Picchu terraces would require countless hours of grinding per stone, with tools that would need constant replacement. For the scale of construction we see, for the number of precisely fitted stones, the time and tool investment becomes staggering, and yet there is no evidence of the massive tool production and stoneworking infrastructure that should have been necessary. Here is another detail that does not add up. The best masonry at Machu Picchu is not in the latest structures. It is in the earliest ones. In most civilizations, you see progression. Early work is crude, and later work is refined as techniques improve. At Machu Picchu, the pattern is reversed. The most sophisticated engineering, the most precise stonework, and the most complex drainage systems are in the foundational elements, the original construction. Later additions and repairs are noticeably cruder. It is as if the builders started with capabilities they later lost or forgot. That is not how technological development typically works. The Incas are credited with building Machu Picchu around 1450 CE under the Emperor Pachacuti. That is 70 years of Inca imperial history before the Spanish arrived. In that brief window, they supposedly developed advanced hydrological engineering, earthquake-resistant construction techniques, precision, stone cutting at scale, and logistical systems capable of moving multi-ton blocks up mountain slopes. That is a lot of innovation in a short time. And here is the thing. We do not see a learning curve in the archaeological record. We do not see generations of progressively better terracing experiments leading up to Machu Picchu. It appears fully formed with sophisticated techniques already mastered. Dr. John Rowe, one of the leading archaeologists studying Inca civilization, noted this problem. The Incas certainly built in stone and created terraces, but the most impressive examples of stonework often attributed to them show a level of technical sophistication that appears suddenly without clear developmental predecessors. Later Spanish chronicles describe finding ruins that the Incas themselves said they did not build, structures they said existed before their civilization arose. The Incas told the Spanish about an earlier people they called the builders, master stoneworkers who created the foundations upon which Inca culture developed. At Machu Picchu, there is evidence suggesting the site may have been occupied or used long before the 1450 CE date traditionally given. Ceramics found in lower levels do not match standard Inca pottery styles from that period. Some researchers, including archaeologist Richard Berger, used radiocarbon dating in the early 2000s and found organic materials suggesting human activity at the site potentially centuries earlier than the conventional timeline allows. The dating is debated, but it raises questions about whether the Incas built Machu Picchu from scratch or built upon something already there. Think about the terraces again in this context. If they represent centuries or even longer of accumulated engineering knowledge, if they are the result of multiple generations refining techniques, if they incorporate lessons learned from earlier failures and successes at other sites, then their sophistication makes more sense. But if they are supposed to be the work of a civilization with only a few generations of stone building experience before Spanish conquest ended their development, then the lack of a visible learning process becomes harder to explain. Recent archaeological work has revealed something else puzzling. Ground-penetrating radar and LiDAR surveys of Machu Picchu and surrounding areas show extensive modifications to the mountain itself, not just terracing visible on the surface, but reshaping of bedrock, excavation, and filling of areas to create level platforms, engineering on a scale that suggests moving thousands of tons of stone and soil. The landscape was not just built on, it was fundamentally reconstructed. That level of terrain modification requires not just labor, but sophisticated surveying, planning, and logistical coordination. It requires understanding geology well enough to know which rock can be cut and which must be worked around, where to place weight and where to avoid it. And here is what is really mind-blowing. The entire water management system is integrated. It is not multiple separate systems built at different times. It is a unified design where drainage from upper terraces feeds into channels that supply lower terraces, where overflow is directed into collection points, where every element serves multiple functions. This is not incremental development where each generation adds another piece. This is unified planning on a massive scale, executed with precision, as if someone understood the entire mountain as a single engineered system before construction began. Modern civil engineering projects of comparable complexity, building in similar environments, require years of surveying, soil testing, hydrological modeling, structural analysis, and environmental impact assessment before construction begins. Teams of specialists collaborate, run computer simulations, test materials, and build scale models. And even with all that preparation, problems emerge. Drainage systems clog, foundations settle unexpectedly, slopes erode in unanticipated patterns. Ongoing maintenance is required. Yet Machu Picchu's terraces, built with bronze tools, stone hammers, and human labor, continue functioning without the regular intervention modern systems require. Something about their design is fundamentally different from our approach. Kenneth Wright, after his extensive study of the site's engineering, made a remarkable statement. He said that if you wanted to build a new Machu Picchu today with modern equipment and materials, you would struggle to match the durability and efficiency of the original drainage systems. Not because we lack the technology, but because we lack the understanding of how to achieve permanent solutions without ongoing maintenance. Modern engineering is built around the assumption of regular maintenance and eventual replacement. Machu Picchu's terraces seem to have been built around the assumption of permanence. The logistics present their own mystery. The nearest quarry for the gray granite used in much of the construction is several kilometers away. Some stones weigh several tons. Moving them to the site requires either dragging them up mountain path or using some method we do not see evidence for. The Incas did not use the wheel for transport. They did not have draft animals capable of pulling heavy loads. According to conventional history, they moved stones using rope, wooden rollers, and massive amounts of human labor. That is certainly possible for small to medium stones, but for the largest blocks, the slopes are steep, the distance is considerable, and the precision placement required. When engineers calculate the effort involved, the numbers become problematic. And it is not just quantity of labor, it is the quality of execution. Every stone in a terrace wall must be placed correctly. If the angle is wrong, If the base is not level, if the fitting is not tight, the entire structure is compromised. One poorly placed stone can create a weak point where water infiltrates, pressure concentrates, and eventual failure begins. Yet walking through Machu Picchu, you do not see those failures. You see wall after wall, terrace after terrace, all built to a standard of precision that suggests quality control measures and construction expertise we normally associate with specialized professional training, not mass conscripted labor working with hand tools. Recent studies of the site have used modern computational analysis to model how the terraces resist seismic activity. The results are fascinating. The flexibility built into the stonework, the way individual walls can move slightly independent of each other, and the strategic placement of larger stones at key stress points all combine to create a structure that actually becomes more stable under earthquake loading. Seismic waves are dissipated through the entire system rather than concentrating at failure points. This is called base isolation in modern earthquake engineering. It requires understanding wave mechanics, structural dynamics, and material properties. Someone who designed these terraces understood those principles, whether they called them by those names or not. There is a pattern that appears at multiple ancient sites around the world. Sophisticated engineering shows up early in a civilization's history rather than as a later development. In many cases, there is a decline in quality over time rather than improvement. Knowledge seems to have been inherited rather than invented, and physical accomplishments that modern attempts struggle to match are common. At Machu Picchu, we see these elements concentrated in the terraces, in the drainage systems, and in the stonework that holds everything together. The terraces are still there. You can visit them, touch them, measure them, and test them. They are not mythology or speculation. They are physical evidence that can be analyzed with modern instruments and methods. And that analysis keeps revealing complexity that should not exist if the conventional timeline and explanation are correct. Soil scientists studying the terrace fill have found proof of sophisticated soil engineering, with materials sourced from different locations and mixed in specific ratios to achieve desired drainage and fertility properties. Hydrologists studying water flow through the system find that whoever built it understood concepts like hydraulic conductivity and groundwater recharge that were not formalized in Western science until the 19th century. When archaeologists excavated some of the terraces for study and conservation, they found the subsurface engineering was even more elaborate than suspected. Drainage channels ran at precise gradients, calculated to maintain flow without erosion. Stone walls extended deep into the mountainside, anchoring the entire structure to bedrock. Filtration layers were placed with specific particle sizes to prevent clogging while allowing water to pass. These are not simple solutions. These are optimized systems that suggest extensive understanding of principles we now teach in university engineering programs. And perhaps most tellingly, when modern conservation work has attempted to repair or reconstruct damaged sections, matching the durability and functionality of the original work has proven difficult. Contemporary engineers and stonemasons, working with better tools and detailed knowledge of the original techniques, create repairs that function but do not quite achieve the same performance level. There is something in the execution, some combination of material selection, stone placement, and construction technique that we are not fully replicating. So what are we looking at when we look at Machu Picchu's terraces? Are we seeing the work of the Incas in the 1450s, a civilization that developed extraordinary engineering capabilities in a remarkably short time before being cut short by Spanish conquest? Are we seeing the culmination of older traditions, techniques passed down and refined over much longer periods than the conventional timeline allows? Are we seeing evidence of an earlier, more sophisticated phase of engineering knowledge that was partially lost and partially preserved in later construction? The physical evidence is there. The terraces function, the drainage works, the stones fit together with precision. These are facts, not interpretations. What those facts mean about who built Machu Picchu, when they built it, and what knowledge they possessed is where the mystery deepens. Because the more closely engineers and archaeologists examine the site's infrastructure, the more sophistication it reveals. And sophistication typically requires time, experimentation, failure, learning, and refinement. Where is the evidence of that process? Visit Machu Picchu, and most people focus on the temples, the Intihuatana stone, and the panoramic views. But look at the terraces. Really look at them. Walk down to the lower levels, where stones still bear the marks of their shaping. Look at how water still flows through channels cut centuries ago. Notice how plants grow in the terrace soil without roots damaging the stonework. Pay attention to the fact that despite hundreds of years of heavy rainfall, earthquakes, temperature extremes, and tourist traffic, the system still works as designed. Then ask yourself, how? How was this level of performance achieved and maintained for over half a millennium with what we are told was available to the builders? The terraces at Machu Picchu represent more than agricultural platforms or erosion control. They represent a challenge to our understanding of technological development, of what was possible at different points in history, and of how knowledge is preserved and transmitted across generations. They are evidence that demands explanation, evidence that continues to puzzle the experts who study it most closely, evidence that maybe the story we have been telling about this place is not quite complete. What do you think you are looking at when you see those terraces? An impressive but explainable achievement of Inca engineering, or something that suggests capabilities and knowledge we have not fully acknowledged yet? The stones are still there, holding the mountain in place, waiting for you to decide.